Hello everyone, welcome back to Tutor Corner LLC. And today we will be going over our second video in our physics playlist. Now our first video was called Understanding Vectors Visually. This second video we will focus on application of vectors in 1, 2, and 3-dimensional mechanics. Okay, so let us begin. And if you would like to reference the first video, please go to my channel, Tutor Corner LLC, and click on the playlist Physics to better understand the first video, which I had talked about the magnitude, direction, and visually representing vectors. So let's start with this video now, and we will start with an example. Let's say you have in a one-dimension space. So in that case, it'll just be a number line which contains the x-axis. Let's say a car was going in that direction. Now, as you may recall from the previous video, the velocity of this car can be represented with a vector. So assume that the vector representing the velocity of this car, remember that a vector has both magnitude and direction. So in this case, this vector, this arrow, has a magnitude or a speed or velocity, and also has a direction going in the positive x, and the opposite is negative x. Let's say that the speed for that was given as 2. In other words, it's 2 miles per hour. Okay? So now the question here is, how do we find the magnitude? Magnitude of v, also represented as v. So the magnitude is basically just the speed of that vector. So we know that that car is heading to the right, positive x direction at 2 or 2 miles per hour. Remember the formula that we have, recall that for vector v, the magnitude is the sum of all the components inside that vector. Okay, so in this case, n is 1 because it's just a one-dimensional vector. It only has the x-axis. So in this case, we will use this formula. So the magnitude of this will be the square root of the square of 2. There are no other components here but the x, so it's the square root of 2 squared. Now we know that 2 squared is 4, square root of 4 is just 2. So that is equal to the magnitude of that vector. Now what's the direction? Direction of vector v. Now I'll give you the formula for this. In this case, it's a one-dimensional vector. Either it's going in a positive x or negative x. And as you can see, this arrow is pointing to the right. Hence, it's going towards positive x axis. And that will be the direction of that vector. So, in other words, that car is going at 2 miles per hour towards the positive x-axis. So that is how we make sense of that vector that's represented by the velocity of that car. Okay? Now let's move on to two-dimensional vectors. Example 2. Remember, you're more than welcome to pause this video if you would like to attempt to figure out how to do these problems. Then you can always unpause the video so you can go over the problem with me. Let's say that now you have the x and the y axes. Okay? Let's say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. The right side of the x, that's positive, so 1, 2, 3, 4. Left side is negative. And then the bottom half of the y-axis is negative. And the top half is positive. So now, let's say we have that car, that same car. Let's say, think of this as some sort of bird's eye view of the car. Let's say the car went 3 to the right and went down 4 times. So this car went to here. Let me use a different color so you can better understand. So let's say it hit a stoplight right there, and that stoplight, it made a right. Okay? So now, that vector, assume that it's given as vector v is equal to, you went 3 times on the x-axis and 4 times towards the negative of the y-axis. So that is the vector that they give us, and the question is, what is the magnitude of also known as, okay? Now the solution to that will be, recall the formula. So the magnitude of vi is equal to the summation of the squares of the components of that vector. Okay? So here, let's call this vx, oops, and call this vy. We're calling this vx because it's traversing across the x-axis, and we're calling this vy because it's traversing across the y-axis, up or down. Okay? So in this case, the magnitude of vector v will be the square root of 3 squared plus -4 squared, and that will give you the magnitude of that vector. So let's go ahead and do the math here. 3 squared, that is 9. -4 squared, that's -4 times -4. 2 negatives multiplied together make a positive 16 in this case. That's also equal to square root of 25. Now, if you take the square root of 25, you get 5. So hence, the magnitude of vector v in this case is 5. Assuming that that was a car, and this was given in miles per hour, so it would be 5 miles per hour. And that is the magnitude of that vector. Okay? Now, the next question, the next part of this question would be, what is the direction of vector v? Okay? So direction, write this formula down, for two-dimensional vectors, theta is equal to arctangent or inverse tangent of the y value, or Vy, over Vx. Okay? So in this case, so remember this formula. That's for finding the direction for a vector in 2 dimensions. So in this case, theta is equal to the arctangent of Vy, which is -4, over Vx, which is 3. Okay? And that will be -4 divided by 3. I'm just using my calculator right now. Equal to -53 degrees. Okay, so as you can see, if you think about it, -53 degrees, that right there, oops, sorry about that, is the angle right here. Theta is -53 degrees, so we can say it's -53 degrees below the plus x axis. Okay, so -53 degrees will be the direction of that 2-dimensional vector. Okay, now let's head on more to a 3-dimensional vector. Example 3. I will not be doing this visually, so we'll just go over the math using the formulas we've learned, which is the magnitude, using the components of the vector, and using this formula for the magnitude. Let's say that a plane, or maybe a bird. Okay, a bird's velocity is represented by the vector v is equal to 1, 2, -2. Now, from that, you could tell that it's a 3-dimensional object since it has 3 components: component 1, component 2, component 3. Now, as you may recall, example 2 had 2 components, therefore it was in 2 dimensions. And example 1 has only 1 component, so it's in 1 dimension. So now we're in 3 dimensions. Okay? The question is, what is the magnitude of V, also known as this? So you're more than welcome to pause the video if you would like, since you might already know how to use the formula, but assume that you are going to go over this with me right now. So the solution would be, recall that the magnitude of a vector in any dimension is the square root of that, oops, sorry about that, of that vector. Oh, I should have probably changed this to I and then N. Sorry about that. This should be I and then N. So yeah, N is the number of dimensions, I is the component. So in this case, this right here, that is the x component, Vx. This one right here is Vy. This one right here is Vz. Okay, so remember we're working in 3 dimensions now. So the magnitude of that vector, let's say that's in miles per hour again. The bird is going 1 to -2 miles per hour in 3 dimensions, will be the square of 1 plus the square of Vy, or 2, plus the square of -2. Don't forget to put the negative number in front of the parentheses to avoid any negative confusions. Okay, so now let's reduce that. 1 squared is just 1, 2 squared is just 4. -2, square that. -2 times -2 is a positive, and positive 4. So that is what we have. You add all those 3 numbers, 1 plus 4 plus 4, that would be 9. Hence, the square root of 9 is 3. Therefore, the magnitude of vector v of the bird's velocity would be 3 miles per hour. Now, hopefully you enjoyed this video and that this explained a little bit more about vectors in 1 dimension, 2 dimensions, and 3 dimensions. And if you have any questions, please don't hesitate to leave a comment in the comment section below. And I hope this video was helpful. Like, share, and subscribe for more. Thank you.